Hello, everyone. Hope you're all doing well. Just a second. Okay. So, welcome again in the week 24 of the MENA Digital Days about the cloud and GCP services. Okay, I try to full screen my slides. So we can start. Okay. So we'll start right now. I am AFAF KELAI from GDGT Baza from Algeria, and I will be with you during this session. So before we start, I would like to remind you, and as every week, about the weekly challenge from the MENA Digital Days. So if you complete six quests, you can win a gift box from Google. And if you go further, you can win a Google Home Mini. Don't forget to fill the feedback form so you can have your attendance certificate by the end of this session. So by the end of the session, we'll learn together how easy it is to connect an application in Kubernetes engine to Cloud SQL instance using the Cloud SQL proxy container as a sidecar container. You will deploy a Kubernetes engine cluster and a Cloud SQL Postgres instance and use the Cloud SQL proxy container to allow communication between them. This is the agenda of this session. I hope we will have time to finish even the demonstration so we can see the concepts that we'll discuss in the session clearly. We'll start talking about some basic concepts that we should know before going further in connection between Cloud SQL instances and Kubernetes. We'll see what is Cloud SQL. We'll talk about containers and the benefits of containerization. Then we'll have a quick reminder about Kubernetes, and then we'll see how we can connect to Cloud SQL and some best practices. Finally, and I hope we can finish the demonstration on Qwiklabs. So first, what's Cloud SQL? Cloud SQL is a fully managed relational database for MySQL, PostgreSQL, and SQL Server. It reduces maintenance costs and automates database provisioning, storage capacity management, and replication, and backups. It offers a quick setup with standard connection drivers and built-in migration tools. Cloud SQL is easy to set up. You select a region and a zone where you would like your instance to be, and that's all. We have also a large option of configuration where you can select the machine type. Okay, where you can select the machine type with the right number of CPUs and memory unit to storage type between SSD and hard disk driver, depending on latency, queries per second, and cost requirements. And set storage capacity. Higher storage capacity means higher performance. Cloud SQL easily configures configure replications and backups to protect your data. Go further by enabling automatic flavor to make your database highly available. Your data is automatically encrypted. You can also create cross-regional replicates to protect from regional failure. Okay, where we have to see also about Cloud SQL that one of the main features is integration, which means we can access Cloud SQL instances from just about one application, easy to connect from App Engine, Compute Engine, also Google Kubernetes Engine, and your workstations. Open up analytics possibility by using BigQuery to directly query your Cloud SQL database. Next, we will see the benefits of containerization. So now let's see what are containers and why we use containers. Containerization of applications brings many benefits, including the following. Like you can see, the portability between different platforms and clouds. It's truly easy once run anywhere. Efficiency through using far fewer resources than virtual machines and delivering higher utilization of computing resources, and much more like agility and security. We've seen in the many sessions earlier during those MENA Digital Days weeks about Kubernetes, about containers, virtualization, and so on. So we can say that containers are lightweight software components that bundle the application. Its dependencies and its configuration in a single image. Running in isolated user environments on a traditional operating system, on a traditional server, or in a virtualized environment. The one big difference between containers and virtual machines is that containers share the host system's kernel with other containers, as you can see on the illustration here on the slide. Now, let's have some quick reminder about Kubernetes. So, Kubernetes is a portable, extensible, and open source platform for managing containers. Kubernetes follows the client-server architecture, wherein we have a master installed on a machine and the node on separated Linux machine. So here, like we can see, the initial or the main component of a Kubernetes master machine, like on the middle, we have the etcd, which stores the configuration informations. It can be used by each of the nodes in the cluster. We have also the API server. It provides all operation on cluster using the API. So the API server implements an interface, which means different tools and libraries can readily communicate with its kubeconfig. We have also the controllers. The controllers here, this component is responsible for most of the collectors that regulate the state of cluster and perform a task. And finally, what we got on the master, we have the scheduler. This one of the key components of Kubernetes master. It is responsible for distributing the workload. It is responsible for tracking utilization of working load on a cluster node and then placing the workload and which resources are available and accept the workload. We finished with the master. So, and here we need to see what we got on the node. So mainly the node got a kubelet services. So kubelet services with its smallest service in each node responsible for relaying information to and from control plane service. It interacts with the etcd store to read configuration details and write values. We have also the Kubernetes proxy service. This is proxy service which runs on each node and helps in making services available to the external hosts. So the following illustrations show the structure of Kubernetes master and node and the communication between each component as I mentioned before. Now, when connecting to Cloud SQL, there is two things you have to think about. First is the path. The path, which means the way you're gonna use to connect. And then the authorization, how to get permission to talk to the instance. Before we go further in this presentation, I hope you understand mainly or basically the functionality of Cloud SQL and then basically the components of Kubernetes, the pod, the masters, and the nodes are the slaves, and the communication between them and how it works. So you can understand further. If you want to understand more about Cloud SQL, you can go and practice on Qwiklabs, or since you got access, or maybe read more about it. But mainly, those are the major functionalities about Cloud SQL, and also with Kubernetes engine. So let's start. When selecting the path, we have two options. The public IP, which is a static IPv4 address accessible from the public internet and require authorization by default, since we don't want anyone connecting to the internet to connect to our Cloud SQL instance. Some of the benefits of the public IP is that you can connect from outside GCP, but you may have a higher latency. The second option you have is to connect using a private IP. A private IP, which is IPv4 address peering to virtual private cloud VPC instead your project. Authorization is not required by default. We don't need any authorization since it's private, but you must have access to the VPC. For the benefits is that usually we have lower latency because you're not connecting through internet, but directly through an internal direct network. So once you decide how to connect, the next step is authorization. When it comes to authorization, there is three options to look at. The first is Cloud SQL proxy. The SQL proxy provides fast, secure, encrypted connections to Cloud SQL database instances without any need to manage allowed IP addresses or SSL TLS configuration details. It uses AM authentications for simple role-based access management. The proxy is great for local development and testing because once it's running on your code and client tools can connect to your local machine to access your database instances. The second option you can use is authorized networks. This is where you specify a list of IP addresses range that are authorized to connect. For private IP, there is similar features called VPC egress firewall rules that you can use instead. Finally, the third option is a self-managed SSL. You can create an SSL certificate for your instance that can be distributed to your application that encrypts your connections. For MySQL and Postgres, this is a client and server-side credentials. For server SQL, this is only a server-side credentials. So To summarize, we have a public IP and private IP. For public IP, you have to use either the Cloud SQL proxy or authorized networks. We also recommend, if you're using authorized networks, to use self-managed SSL. This encrypts your data and makes sure that no one can read unless they have a certificate. However, this is automatically done by the Cloud SQL proxy. So if you want to use it, you don't have to worry about managing your own SSL. Next, let's talk about Kubernetes to Cloud SQL. There is 3 different ways that usually people use to connect. First, direct using private IP. Second, the proxy as a service. And third and finally, the recommended way is the proxy as a sidecar. Because private IP doesn't require any authorization, you can just put in your private in your application and connect directly to your Cloud SQL instance. In order to access to that private IP, you have to be on a VPC native Kubernetes engine cluster. This is very important to know. You may ask yourself if using the private IP is that much easy, since both application and proxy are on the same internal network. Why we should, or maybe why we have to use another way? And you maybe ask yourself, do I still need to use the proxy? With the proxy, there is the hard part, which is the installation and the configuration that will take some time from yours. But on the other hand, or maybe the advantage, you have a strong IAM authorization and strong encryption for your data of your application. For the proxy, the advantage is that you don't have to worry about the setup. So it's automatically, or basically, there is no configuration since you can connect directly via IP, but it requires a VPC native Google Cloud Engine cluster and weak authorization. Anyone from your network can connect to your database. So I think here we've understood why we should use a proxy and why there is more advantages on using a proxy versus using a private IP. When you run a proxy, when you run a proxy as a service, typically you do this in a separate deployment from your application. So as you can see here, on the left, you have the application. So we have our application here on the left, on the application pods have been deployed. And on the right, we have the proxy pod, which have also deployed. And your application is going to connect directly to the proxy, and then your proxy is going to route your connection directly to the Cloud SQL. One of the downside of this is that the traffic between your application and the proxy is not encrypted by default. The proxy doesn't offer any encryption. The client side only encrypts the traffic coming out before it's getting connected to the Cloud SQL. Another disadvantage is there is no authorization. Anyone in your cluster can connect to the proxy, which means anyone on your cluster can connect to Cloud SQL. Another disadvantage is there is a single point of failure. So if all applications are using the same deployment of proxy to run, if that deployment fails, all of your applications are no longer we are all the applications fail. So all the applications are no longer able to connect. So if something goes wrong with the proxy and it stops operating correctly, all of your applications fail instead of just one instance. Finally, another disadvantage is the application on the proxy aren't necessarily running in the same region, which means higher latency. Those are some disadvantages of using the proxy as a service. That's why the Google Cloud team recommends to use proxy as a sidebar. First, what does the sidebar container do? As we said earlier, a pod is the basic atomic unit of the deployment in Kubernetes. Typically, a pod contains a single container. However, multiple containers can be placed in the same pod. All containers running on the same pod share the same volume and network interface. This is really important to remember that on the same pod, all containers on the same pod share the same volume and network interface of the pod. Actually, the pod itself is a container that executes the pod command. Its role purpose is to hold the network interface and the Linux namespace needed to run other containers. Well, we call it a sidecar pattern because you can think it like a motorcycle with a sidecar. It's attached to the side. You still have your main application here. And then you have the Cloud SQL proxy attached to the sidecar right here. The application can connect to the Cloud SQL proxy directly, which then connect to the Cloud SQL. And because this is a pod, those two units are attached always together. If the Cloud proxy fails, the application also fails. But if the application fails, the Cloud SQL is still running on other pods. It's authorized because the Cloud SQL proxy is inside the same pod as the application. Only the application can access. You don't have to worry about other traffic accessing the proxy that not supposed to. It's also isolated. If the application fails or the proxy fails, you don't have to worry about the rest of your application going down because it's just that pod who failed. And finally, it's encrypted. So your data is fully protected and no worries about any accessing from the external traffics. Okay, so now I think that we're convinced to use the Cloud SQL proxy sidecar. But how? Let's talk about deploying a cloud proxy. The first thing we need to do is to pass credentials to the proxy. Then we mount the proxy as a sidecar. So when passing credentials, again, we have two options. The first is workload identity. This is where you can map Google Service Account, the GSA for sure, or to a Kubernetes service account. You don't have to worry about managing any secrets, but it's a GKE only feature. That means you have to use GKE cluster if you want to take advantage of this. If you're not using a GKE cluster, you still can use a service account K file. This is where you have a service account credentials stored in a JSON K file. The downside is that you have to worry about keeping track of the JSON K file and routing it, but you're able to do this on Kubernetes instance. Option one is workload identity for GKE. Like we can see on the left here, we can see the application and the Cloud SQL proxy attached on the same pod. We can use the same account to represent both the application and the proxy. In order to set up this, the first thing we can do is to create a Kubernetes service account. It will generate a metadata containing the Kubernetes service account. The step number 2 is binding the Google service account with the Kubernetes service account. So we have, there is 2 steps here. The gcloud command to specify which Google service account you're using and which Kubernetes service account. The second one is the kubectl. It allows us to connect to our Kubernetes service account, right? Here, like you can see the kubectl with the service account. And finally, when we're done with those 2 first steps, we need to add a Kubernetes service account to our application. All we need to do is to add the service account we specified in the first step and bound on the second step. Okay, for the option 2, which is the service account K, you will use these credentials to generate token for an API. So like you can see here, there is mainly 3 steps, same as the first option, but here we will create a SAK with the gcloud command to specify the service account K, and we will create and put it on the JSON file. The step number 2 is we need to turn a K into a secret using the command kubectl create secret. It's a generic secret K, and we will specify which file we're gonna put it in. Like you can see here, we have a k.json. And finally, the third step is we will mount it as a volume. We will put like a file, the file we specified in the 2 first steps, and put it on the application file. We specify it here, like we can see the volume name. We put here our SA secrets name inside the application. After you decided to mount your credentials, here we got to mount the sidecar. So proxy runs on its own container, and this will make us the possibility to share a pod with the main application. And like we can see here on this illustration, an explanation of how the application and the Cloud SQL proxy are on the same container. To mount a sidecar using a TCP, for example, the advantage is that we will have the same configuration before that we did earlier, and we will add on it the configuration for the to mount the sidecar. For example, here we have the by default, the containers configuration by default. And here, up in here, we have the name of the application. And then we have the image from the Docker file we specified. And then we got here the comment. For example, here we use the gcloud SQL proxy command. If we want also to make it a private IP, we have to enable it, the IP, and make it private, the IP address type, and make it private. For the service account, also to specify the route to the file, we can make it as a instruction here for service accounts. We put it and we put the link to the file, the JSON file. And finally, we have the instance connection name with the TCP. We can make it by default for the MySQL or PostgreSQL, or specify the our port. So here, those two main stuff we need to specify when mounting the sidecar. There is other resources you can go and check for, like the Cloud SQL proxy on GitHub, and also we have the Cloud SQL GDBC socket factory. Now I think that we don't have a lot of time, so we're gonna see here the demonstration on Qwiklabs. Since you have all of you, I think, the access to the Qwiklabs platform, like you can see here, we're on the Connect to Cloud SQL from an Application Kubernetes Engine lab. This lab dure normally on 1 hour and 15 minutes. But since we normally understood some basics about Cloud SQL, about Kubernetes, and how to connect, especially using the sidecar, the proxy sidecar, I think that you can do it easily here, since the first step we're here before to start the lab is to read well how to use this lab. So you can connect directly via the username, the password given by the platform. But before here, we got the architecture. The architecture that we talked earlier on the presentation, talking about that the application of the Cloud SQL proxy are on the same pod, and they can communicate with the service accounts K, since we are using a proxy sidecar. After we set up the requirements, we go to deploy our applications. But before that, you will have a link to the applications on the GitHub repository. So you have to clone it. Here is, you have to execute the command as mentioned on the lab. Don't try to execute another application, or maybe it works if you work on your own application, but here on the lab, so you can complete it and have 100 point here, you need to use and clone the project proposed by the lab here. So after cloning this link here on GitHub and go to the directory for this demonstration, we go to the deployment when we have to specify a username and a password for both pgadmin and Cloud SQL instance. Then we need to remember the password that we worked with, because we need to enter and connect to the Cloud SQL. Once creating when deploying the create.sh, it will run some scripts which contains a lot of informations and so on. It's automatically done by the GKE, and you don't have to worry about it. Then after we continue the deployment, we can have we go directly for the validation process, and the validation is fully automated the validation script check for the existence of Cloud SQL instances, the Kubernetes engine clusters, and the running pods. All of these resources should exist after the deployment scripts is completed. And as we said before, this was automatically done while deploying the SH documents. After the validation, which suppose the final step, we can have teardown, which is also fully managed, which will delete every resource created on the deployment scripts using this command. So make teardown, it will delete resources and delete all instances. And while executing our commands, we may have some troubleshooting in our environments. And how by having this error, so we finished our connection to the application and connect the Cloud SQL to the Kubernetes application by the validation, and that's it. I hope you got it and you understood why we should use the proxy sidecar. And I hope you can execute this lab. I didn't do it because we don't have much time. Now I will see if there is any questions. Let's see. I think it's really I'm asking about the presentation. Second, I think. Okay, we have here a question about the presentation. So I can share my presentation with you if you want. I will leave it for the, you can ask the administration here, the Hassan maybe can help with this. I'll download it. The link of the GitHub, you can find it on the lab. The GitHub link of the application here is here. For those who are asking about the two last links I talked about, send it for you right now or maybe later. Here, you maybe can see. I will send it. I don't think there is questions, so thank you and good luck. I hope that was helpful for you all, and thanks.